Okay, so the first thing to do with your calculator is to make sure it's in the original mode that it came in when you first bought the calculator. So to do that, you press Shift 9, you get the clear menu, click 1 for setup, the equal sign for yes, and AC to acknowledge that you've reset your calculator. And then you can click on Shift Mode 3 to make sure any calculations you do in paper 2 in the trig or geometry are in degrees. Okay, so 2013 then began with paper 1. We'll look at paper 1, began with complex numbers, and the basic skills you'll need to know for complex numbers. You should be able to plot complex numbers on an Argand diagram. That's what they asked you to do here. Okay, and you should be able to find the conjugate of a complex number. That's x bar, and you normally find the conjugate, remember, when you're dividing one complex number by the other. You should be able to find the modulus of a complex number, and that's the distance from a point, to the origin, or this point to the origin. That's the modulus there, that distance, or that's the modulus of that complex number there. You should be able to divide complex numbers, and you should be able to multiply complex numbers as well. So in 2013, they asked you to plot, they gave you 2 points, and don't get confused by them calling them Z1 or Z2. It's just so that they can differentiate between the two different complex numbers in the question, okay? So they gave you 2 complex numbers, they asked you to plot them, so you should be able to do that. And then they asked you, from your diagram, is it possible to say that the modulus of Z1, the distance of Z1 to the origin, is greater than the distance, the modulus of Z2, the distance from Z2 to the origin? Is it possible to say that? Well, here's Z1, that is greater than this distance Z2. So yes, it is, and that's why. Okay. Now they wanted us to verify algebraically that the modulus of Z1 was greater than the modulus of Z2, and just remember the modulus formula, for any complex number is equal to a squared, the square root, of a squared plus b squared, and where a and b are, if for example in this question Z1 is equal to 3 minus 4i, a is 3 and b is minus 4. So this is B, sorry. So if you're asked to verify one modulus greater or smaller than the other, just work out the modulus using the formula. So for Z1 it's 5, for Z2 it's root 5. So that verifies that Z1, or the modulus of Z1, is greater than the modulus of Z2. Finally, you're asked to divide one complex number, Z1, by the other. So remember, and you have to give your answer in the form of x plus yi. In some exams it's a plus bi, don't worry about that. But basically, to divide one by the other, you simply write the one over the other, then you look at the lower one, and you find the conjugate of that. You find the z2 bar, which is 1 minus 2i, and you multiply above and below by the conjugate of this lower one. And be careful, it's like multiplying out factors, 3 minus 4i by 1 minus 2i up here. That's factors, so you get 3 by 1 is 3, 3 by minus 2i is minus 6i, and so on. Okay, and you do the same under here. You gather the like terms, and remember that this plus 8i squared, at the beginning of the question they tell you that I squared here is equal to minus 1. So you keep that in mind at some point during the question, because you will plug in plus 8 by minus 1, that's equal to minus 8. So that's what's happening there. And again, you simplify and reduce further, and remember that minus 5 minus 10i over 5 can also be written as minus 5 over 5 minus 10i over 5, which gives this answer here. The second question in 2013 then was a functions question, okay, and basically the diagram shows the graph of the function. There's your function there. Now remember, they can say f colon x maps is such that x maps to 6x minus x squared. So there's another way of saying the function, but in this question they gave it like this. In the domain, x is greater than or equal to 0 and less than or equal to 6. X is from the set of real numbers. Don't worry about that too much. Basically find f of 0, f of 1, f of 2, blah blah blah, and complete the table below. So basically they're asking you to find the output of the function 6x minus x squared, the output y when the input value is 0. So when I put 0 into that function, I get for x, I get 0 out. When I put 1 into this function, I get 6 by 1 minus 1 squared is 5, and so on. Now remember, you can also use your calculator to find these values here using the mode and table function on your calculator, where you can input the function f of x equals 6x minus x squared. So that bit is straightforward enough, really. For the exam then, they asked you to use the trapezoidal rule in that exam, the trapezoidal rule, to estimate the area of the region enclosed between the curve and the x-axis. So there's the x-axis, there's the curve. Okay, so they want to use the trapezoidal rule, so it's in the log tables, but basically, and just know that, you know, the trapezoidal rule tells you that the area is given by h over 2. Now this is h here, it's this value from here to here, there to there, you know, that's h. Okay, so be careful of that. H over 2, all multiplied by y1. Now this y1 is the first height there, and in this case it's 0, plus yn, which is the last one, and that's 0. Always plus 2 times then the sum of the remaining heights inside the curve. And that all works out to be a half because h is equal to 1 over 2 times 2 by, all of this sums to 35, so that you get the answer to be 35 square units. Okay, so question 3 is from the numbers part of the course, number section, and for this section you really need to know how to set your calculator so that it can give answers in scientific notation or standard form like this, correct significant figures, and also that you can set up your calculator to give answers as required here to 2 decimal places like here. Okay, so we'll have a look at how to do that in a moment. So for the first part of the question then, the mean distance from the Earth to the Sun is given there in kilometres, and they want you to write that number in scientific notation or standard form. So all you do is you type the number into your calculator, input the number there, press Shift Mode 7 for scientific notation 2 to give 2 significant figures, and you should get your answer like that. So know how to set your calculator up like that. Now for the second part, you're asked to set your calculator so that it gives the answer to correct 2 decimal places. So you can do that, it's down here. So now you can press Shift Mode 6 to fix the answers and press 2 for 2 decimal places. And don't forget to press the equals sign and the SD button as well. So having done that, then you simply just type 2.1 into your calculator, hit equals, hit SD, and you should get 2.10. Square root of 5 equals, and hit SD, 2.24, and you can try those other ones yourself. To calculate this one here, you can make use of the fractions button, so you hit the your brackets first, type 1 plus, then use your fractions button, which is a very useful button on your calculator, and all to the power of 10. So you can use the x for this. To put 10 here, you use the x to the square button, and you should be able to type in the 10 there just by using the blue button on your calculator to go up, down, and left and right. So have a go at setting up that bubble with that kind of configuration inside it. Get comfortable with your calculator. Then they were asked to just plot the values on this number line here. They gave you 2 to 3 and 2.5, and you had to mark in the different bits and pieces. And the last part of the problem then, they asked you to solve the equation 27 to the power of 2x equals 3 to the power of x plus 10. Okay, so just with any of these problems, which are basically equations with indices or powers or exponents, the idea always is to look at the two base numbers and match them. So you have to somehow rewrite 27 in terms of 3, and they'll always give it to you like this. They might give you 16 and 2 or 4, they might give you 8 and 64. So there's always a way of realizing that 27 can be written in terms of 3 as 3 to the power of 3. That 3 multiplies by the 2x give you 6x. And now that the base numbers are the same, you can just bring down your 6x and your 3x plus 10 and just solve for x. So we're going to leave our calculator, it's still set up to 2 decimal places, but after this then we can just reset it back to the factory mode, which you can do by Shift 9 1 for setup, equal sign for yes, and AC to complete the reset. But just leave it in the 2 decimal places mode for the moment. And given that r is equal to this, find the value of r. So basically I want you to use your calculator to solve this problem. So you do open bracket 1 plus 0.015, close bracket, and then use the x to the square button, and that puts the little box here for you, and you can type in 12 and equals, and you should get 1.20. Now it's good to set your calculator back to the normal mode. Shift 9 1 equals AC. Okay, so look at this. This is the arithmetic question. Sorry, I should have mentioned that. And Michael has a credit card with a credit limit of €1,000. Interest is charged at 1.5%. Now we're going to have to change that percentage to a decimal. So the interest is 1.5%. So if we divide that by 100 on your calculator, we get I expressed as a decimal as 0.015. Michael gets a bill at the end of each month. At the start of January, Michael owes 800 on his credit card. If Michael makes no repayments and no more purchases, show that he will exceed his credit limit after 15 months. Well, we'll have to use the compound interest formula here, where T is going to be our 15 months. Our interest is charged monthly, so we can use I 0.015. The present value, he owes 800 on his credit card. How much will he owe in 15 months? What will the future amount be? Okay, so you just plug in your values here, and you should see that you should get that answer there. Okay, so for part C of the arithmetic question, it's about working with the exchange rate. We're told that €1 is the same as 0.8473 pence, 84 pence, or 0.8473 pounds. Okay, so we want to find then what £95 will cost in euros. Okay, so what's £95? We'll keep our pounds under our pounds, and what's that going to be in euros? Okay, so we've set up our mechanism like this. Okay, so we can cross multiply. We can just say what we're looking for in euros multiplied by 0.8473 is equal to 95, because it's 1 by 95. So what we're looking for in euros must be 95 divided by 0.8473, and that's €112.12. So this is the amount that will show on his credit card. He bought an item for £95, but actually, given this exchange rate in euros, this is what he'll be billed. Okay, so question 6 then was a quick differentiation problem. So you're just basically given y equals 2x cubed minus 3x squared minus 1. Find the dy dx, or as we know it, another way is f of x, or if it was a function or a plot, we plotted this function, would be finding the slope, but not here. We're given y, so we find dy dx. So 3 by 2 is 6x squared minus 2 by 3 is 6x, and this just fades away. Okay, and the second part then you're asked to differentiate all of this multiplied by all of that. So the first thing you need to do is say, okay, well, y is equal to all of that multiplied out. You can kind of bounce that out yourselves and see how that works out. Okay, and that gives you all of this. So you gather all the terms. So you have a term for y, and so dy dx then 5 by 2 is 10x to the 4, 4 by 3 is 12x to the 3, minus 3x squared, plus 2x, plus 5. And this fades away. And just so you know, this part of the question in 2013 is no longer part of your course. It uses a quotient rule that's not on the Project Maths course anymore. Okay, question 6 then, functions question again. The diagram shows the graph of the quad, so they've graphed the quadratic for you. It's always a parabola, remember that. And a line L1. Okay, so here's L1 here. L1 passes through the point 2, 0, that's there, and is a tangent to the curve at the point minus 1, minus 3. Find the slope of L using the slope formula. So you've this point and that point, you find the slope of L. Then you're asked to find f of x, the derivative of f of x. So you're asked to differentiate this. So if f of x is x squared plus 3x minus 1, f dash x equals 2x plus 3. Now remember, I've said it earlier for question 5, but the first derivative of any function actually gives the slope of the function at any point x. Okay, and they go on in this question actually then to ask you to verify, bear with me now, to verify your answer to A, okay, that the slope is 1, by finding the value of f dash x at x equals minus 1. In other words, find the slope of the function at the point where x is equal to minus 1. So you simply take your slope function there, or your derivative, which is the slope, f dash, when minus 1 is the input, what's the output? And the output is 1. That's the slope. Okay. We could put in another value for x somewhere else, say a value here, and that will give us a different slope. If we put, say, minus 2 into here, we get a different value here. But at that point here, the slope is 1. And remember what the slope means. It means for every 1 unit in x, the graph rises in y by 1, in this case. Okay? So I said there actually the derivative at x equals minus 1 is equal to the slope to the curve at x equals minus 1, and the slope of the curve as well at x minus 1. The last bit then, the line L2 is perpendicular to L1. Okay, so you should immediately be thinking about what the slope of L2 looks like. Find the coordinates of the point at which L2 touches the curve. So the slope of L1 is 1, so the slope of L2 is 1 inverted, which is 1, and you change its sign, it's minus 1, okay? And the slope function that we derived from the function f, the first derivative f dash x, is also equal to the slope of m2, so we can equate that then we can say 2x plus 3 equals minus 1, this slope here, so 2x is actually equal to minus 4, x equal to minus 2, you should say there. And then if we pop that in here, we can find the corresponding y point. What is, if I put minus 2 into the original function x is minus 2, I can find the corresponding y coordinate that's minus 3. So that gives us the point of contact x and y minus 2, which we solved here, minus 3. Question 7 in 2013 was all about generating linear equations to solve a real life problem. Okay, so you were told that two identical cylindrical tanks, A and B, being filled with water at a particular time. The water in tank A is 25 centimetres deep, and the depth of water increases at 5 every 10 seconds. And at the same time as this, the depth of the tank in B is 10, and that has a rate of 7.5 centimetres every 10 seconds. So that start off time, we can call it 0, and then we have 10-second intervals. Okay, and this is our x value, if you like, and these are our y values if we were to plot these. So we know at the beginning that piece there was 25 centimeters depth of water in one and in the other, but after 10 seconds, we added 5 centimeters here, so we got 30. 25 and 5 is 30, and for the other one we added 7.5. We keep adding 7.5 there, we keep adding 5 there, and we generate a table showing the depth of water of each tank over 2 minutes. Okay, so we got up to 120 seconds there. In part B, we're told that each tank is 1 metre in height, so how long does it take to fill each tank? Well, you keep going up along here until you get to 100 centimetres, which is 1 metre, and you'll see that for tank A it takes 150 seconds, and tank B takes 120 seconds. So for part C then, we're asked to write down a formula which gives the depth of water in the tank at any given time. Okay, so we're going to have to equate depth to time, and we're working with seconds here, so we have to find how much the depth changes with respect to time, and we're told early on that it rises 5 centimeters per 10 seconds. So what's that in 1 second? So it would be 0.5 centimeters per 1 second if I divide above and below by 10. So our rate, our depth with respect to time must be equal to the initial depth of 25 plus this rate of a half a centimetre per second times the number of seconds. And the rate then in our other, in tank B, is actually 70.5, should be 7.5 divided by 10, so 0.75 centimetres per second. So D after t seconds in this case will be our initial 10 plus 0.75 t. Next, we're asked to plot for each tank, draw the graph to represent the depth of water in the tank of 2 minutes. So you have the table data overleaf and the other two graphs you get, and find from the graphs how much time passes before the depth of water is the same in each tank. So that's basically where they intersect. So the time is 60 seconds. And you can verify your answer then. You're asked to verify your answer here using your formulas. So if you have your two formulas and if you equate them, you'll find that t is equal to 60 seconds. Okay, so you equate this value, or this equation, with this equation because they should have the same value of t when the depths are equal, as we've just found out here, and you get t is 60 seconds. Question 8 in 2013, patterns and sequences, so it's the longer version. So some years you'll get it as question 4 or 5 in paper 1 early on in the paper, but in 2013 you got it as a longer question. So it's basically two brothers, Owen and Peter, began work in 2005. Starting salaries are given here, and this is 2005. Okay. So this must be 2006. respectively. It's 2006 and so on. And so you complete the table because you're given that Peter starts at 17 and he increases by 1,250, whereas Owen increases 500. So you fill the table in. In what year will both brothers earn the same amount? And it's 5, 6, 7, 8, 9. It's here, 2009. Okay. Owen claims that their salaries over the years can be represented by an arithmetic sequence. What is an arithmetic sequence? It's a sequence in which the difference between any two successive terms is a constant. Okay. Do you agree with Owen? Yes, we would agree with Owen because we're adding a constant to one guy's salary. And although it's a different constant, we're asking a constant to the other fellow's salary too. Then find in terms of n, a formula that gives Owen's salary in the nth year of the pattern. So you're looking to generate and use the nth term rule. You know A is 20,000, D is 500. There is your nth term rule for that guy, Owen. And you use your formula otherwise to find Owen's salary in 2015. So you have to go back to your table and you have to realise that actually 2015 would be the 11th. The 11th term, 2015, would be 11. Okay, so knowing that, then you know that your n value is 11. So you're looking for T11. You know you have the formula, and you find that it's 25,000. So question 3 then in 2013 came from the number chapter, and part A said, the mean distance from the Earth to the Sun is 149,597,871 kilometres or 149 million odd kilometres. Write this number in the form a by 10 to the n, where a is between 1 and 10, and it's an integer, n is an integer, sorry, and it's correct two significant figures. So basically all you need to do is type the number into your calculator here, press Shift Mode 7 to give you the standard notation or scientific notation, and then hit 2 to give your answer in two significant figures, and that should give you 1.5 by 10 to the 8. Then we're asked to find in terms of n a formula that gives the total amount. So if you're looking for total amounts, then you're starting to think about the sum of the nth terms. So using this rule here, S of n equals n over 2 by 2a plus n minus 1 by d. Sorry for all these squiggles here, I can't get them off the screen for some reason. We know a is 17,000, d is 1,250, so we're looking to find S of n. And so we get the rule as 625n squared plus 16375n. And we have to use this formula now. This Sn equals the sum of the first n terms equals that. I was find the total amount earned from the start of 2005 up to 2015. Okay, so we know that n again is 11. So we have 625n squared plus 16375n. We put our 11 in and we get 255,750. Finally, give one reason why the graph below is not accurate way to represent Peter's salary. Well, the graph is not accurate because it shows the salary increasing constantly throughout the year, which is not true. His salary increases in steps at the end of each year, so it should really be like that, flat, up, up. It should really be like that, and actually to represent that mathematically, we haven't covered it, but you'd use dotted lines. So question 9 in 2013 was actually differentiation problems, so be careful and look out for those. But the company has calculated the daily cost in euros to produce X items is given by the production cost function, C of X equals that. The total daily income from the sale of X items is given by a revenue function, another function that equals that. Okay, the company assumes that it will sell all the items it produces. The company produces 20 items a day. Find the production cost and total income. Well, X is 20. Plug that into here. That's your input. Your output is that. And the income, Rx is 1200, X is 20 again. That's your income. So the profit is one minus the other. Find a general expression for the profit the company makes from the production of X items. So profit, basically P of X, must be equal to the total income minus the production cost, which is reflected here, and you basically take Rx and Cx and you work out what Rx minus Cx looks like, and you can see there that it looks like 1200x minus 5x squared minus 750x minus 3000. It's okay. So the next question is, how many of these items will the company have to produce in order to make a maximum profit? So when we're talking about differentiation and maximum profits, then we find the first derivative of this. Okay. Okay, so our first derivative, p dash x, looks like 2 by minus 5 is minus 10x plus 450. This fades away. You know, this is also the slope of a curve of this function if we plotted it. Okay, and you know, remember the slope of the curve at its max or min is 0. So we can say that f dash of x equals this, then that's also equal to 0 at the maximum point. So we equate that to 0, in other words, and we find that x is 45. So that's the maximum profit that they can achieve at that value. Okay, and find the maximum profit that the company can make. So the approach to that is we have our profit function here. We know that x is the value that we use to get our maximum profit. So we let x equals 45 and we put it into this original function and we get 7125. So that's the same thing really as finding the corresponding y value to this x value here. Finally, the production costs on a particular day amount to 11,000 euros. Find the number of items produced. Well, there's the function there, and that's all equal to 11,000 euros. So you bring this 11,000 into here, you get minus 8,000. You can divide everything there by 5. You get this, and you solve to get the factors are that. So you can say x minus 10 equals 0, x equals 10. That's the number of items. Or you could say x plus 160 equals 0, x equals minus 160, but that's silly and we reject that. Okay, we accept that x equals 10.